I'm Matt Swartley with Chariot Solutions, and I would like to introduce you to Mark Fussell, co-founder, maintainer, and steering committee member for Dapr. Mark is going to speak with us today about what exactly Dapr is and how it makes building microservice applications a joy on any platform. So please welcome Mark Fussell.
Well, thank you for that wonderful intro. And it's a joy to be here and to present to you about the distributed application runtime, otherwise known as Dapper. And as the intro said, I actually worked at Microsoft for many, many years where we started this project and then left Microsoft in order to found a company called Diagrid, which is going to be based upon building software on top of Dapper. But as a co-founder of Dapper, I wanted to talk to you about how useful it is for you as a developer and what its capabilities are. But kind of given this is an enterprise conference, we should give a little state of what the enterprise developer landscape looks like. And there's been a big shift over the last 5 years. It's kind of become a strong relevance amongst enterprise developers now to build these scalable distributed services. Actually you're taking code that you typically built that was just inside an enterprise and scaling it up to run as a service. And so these resilient scalable services are kind of one of the main driving factors for cloud services that are built by enterprises, whether they're providing a SaaS service or an API or whatever they're offering. And the typical way that these things are built, they're built with a microservices architecture is one way, if you're lucky enough in order to be able to start a greenfield project. But quite often, a lot of enterprises have existing code and are having to migrate and mutate that into a scalable architecture. But of course, as a developer, you want to build and focus on the application itself and not about infrastructure. And so there's a trend towards building things with a serverless API, multiple languages, using the right tool for the job in order to do that. And so developers want to be able to be productive and be fast to be able to build these scalable services. And a typical application, and this is purely fictitious here, has a number of different services, how they communicate with each other. They typically may be event-driven by publishing messages to each other. They may be able to call each other directly with a sort of service, RPC-like calls. Some of them are stateful, like this card service here, and are long-running and want to maintain some state. Some of them are stateless and simply sort of send events on your behalf and can recover that. And there's a lot of communication to external systems, whether that's external databases or to queues. And so these applications can become complex, but the architecture of microservices has become a de facto way because it allows you to deploy these independent, versionable, scalable units. And it allows, importantly, for enterprises to be agile in terms of how they release their code. So it's the agility and the way that these microservice architectures has evolved that is the benefit to organizations. But as with all things, there's pain in doing this, and really there's limited tools and the runtimes available to build these sort of things. A lot of developers have to still be told that they have to build on sort of a VM platform or a set of physical machines, or they're not given the tools that they want, or they have to find them themselves. Often, if they choose a particular platform, they get locked in on that. There's a lot of platforms that say, yes, we'll provide you a set of services, but it'll only be Java, and you have to be locked into this particular platform. And often these code choices you make are not portable, so once you have chosen a particular language or framework, you're stuck with that for a long period of time. So all of these barriers is what we wanted to break down with the open source project called Dapper. And that's exactly what it does. It allows you to build these connected, distributed microservices type applications faster. And that's what I'm going to demo to you today. And so I want you to take away from this is that Dapper is a set of best practices that have been taken over many, many years of industry, codified into a set of building blocks. And you can use them as a developer, whether you use just one of the APIs or two of the APIs, it's your choice. But it allows you to become very powerful and just come at it from where you are today. So Dapper is all about making developers more productive, building these scalable, resilient applications that are portable across clouds. And what it does is it provides a set of APIs. It provides this over HTTP or gRPC. And it basically, there's a lot of, you go out there and there's a lot of documentation that says, here's how you should build, and gives you sort of architectural guidance, but there's not a lot of practical codification of that guidance. So for example, say you're wanting to build an event-driven application that does publish and subscribe messages, where you have a set of services that want to listen on some events and you want to publish some messages from other ones. and it's be event-driven. It's a very common design pattern. How do you achieve that? Well, Dapper provides a building block or an API called publish and subscribe that allows you to achieve that very goal. And so the building blocks of direct service-to-service calls, long-running stateful applications, event-driven publish and subscribe, talking to external systems by publishing and being triggered by events, seeing observability. There's an active framework that allows you to build a particular type of resilient stateful application. Being able to retrieve secrets and configuration are all these things that you can take control of as a developer. And whether you choose to use the APIs directly, there's also sort of built-in SDKs. And I'll show you both. I'll show you what the API HTTP view looks like, and I'll show you sort of this SDK view. And the SDKs on top of the API, these APIs just allow you to have a natural, more language-specific role for you as a developer. And then importantly, Dapper will actually deploy on any cloud or infrastructure. It works very well on top of Kubernetes, but that's just one of these platforms. You can run it on physical or virtual machines. You run it on, on whether you run it on public cloud or you can run it on premise. It's very portable, and that allows you to be agile in terms of how your choices are made. So the goals of Dapper is give you these best practice building blocks, give you a consistent set of portable APIs, allow you to talk to it from any language where you come from as a developer, adopt standards, be cloud agnostic, be pluggable in its approach, and importantly, build a great community, be a community-driven, vendor-neutral product. And that's where Dapper is having huge success in terms of its community growth and its community adoption over the last few years since it's been out. So how does Dapper actually work, and what does it, how do I think about this? So at its heart, really think of this as a process that runs next to your code. It's a sidecar, and it does all the heavy lifting for you. So you launch your app, Dapper launches next to it, you talk to it over these HTTP or gRPC APIs, and then it does all the heavy lifting on your behalf, a bit like a helper, a bit like a butler, a bit like a sidecar, in terms of the analogy of a sidecar on a motorbike. And you then call, as a developer, literally local host API calls for a particular API signature in order to achieve the goals. So if I want to call the new order method on the cart service application, wherever it's running, I can use the invoke API, and Dapper will do all the heavy lifting of discovering the cart service, calling the new order method on it, and doing that for me. If I want to save some state, because I want to make a long-running stateful application, I can simply call the state API and say, save this item number 67 into the inventory database. And that database can be any number of the databases that are integrated with Dapper. There's 26 of them today. So it's your choice. And you see here that this is agnostic, and you'll see that as a theme as we go through. I can publish messages or retrieve secrets. So this is Dapper sidecar model. So let me show you this and dive in now so we can have a feel of what Dapper looks like. So I'm going to switch over here to Visual Studio. First thing, actually, if you want to get started, if you go to the dapper.io website here, and if you click on Getting Started, this takes you here to a Getting Started topic, and it allows you to tells you how to install the Dapper CLI, set up your local environment. And I'm just going to go through here this how to use one of these Dapper CLIs. So this is a great APIs. This is a great getting started tutorial of how to get intro to Dapper. So you can install this Dapper CLI here and go through this getting started guide. I've done that on my machine. And what that ends up with is I end up with a Dapper CLI here. And you see that the CLI has a number of different commands. The one to get started with is I can do Dapper init, and that establishes a development environment for using Dapper on my machine. And that includes, for example, setting up Dapper as well as some useful Redis and Zipkins running containers in order for me to try out building stateful applications. So this Dapper init has just set up a development environment for me. And so now I can take advantage of the Dapper run command. And if I just clear this screen here, and if I do a Dapper run command, I can launch Dapper as a sidecar by itself. And importantly, I can give it a unique name. So I can say, I want to launch the Dapper sidecar and give it an application name of my app and talk to it over port 3500. So here I am going to run the Dapper CLI. It launches Dapper. It gives you some logs about what's happening. if I move this over here to one side, I can use the Dapper CLI just here at the moment to do Dapper list, and you'll see that I have a single application, my app, running with a port that I can talk to. So now, given this, I can just call the API directly. You'll see that I have an example above me here already. If you'll see that I can actually call and do a curl command, and I can curl onto localhost 3500, call the v1 state API. Let me go back one more here. And you'll see that here, I'm going to use this, the v1 state API to call a local host, call this my local state store. My local state store is that Redis state store setup, and I'll show you how I get that configured. It's through a component definition. But all I'm going to do is I'm going to store some key value information. I'm going to store a key called name and a value called Bruce Wayne. So if I do this, I've now stored some information in my configured state store, whatever this is. This can be a Redis state store, Oracle database, SQL Server database, any number of the innumerable types that have been configured. And I can retrieve this back as well. So I can actually go and get the name for this thing. I can go and call on to my local host state store and retrieve the name for this, and I get back Bruce Wayne. So very straightforward in terms of just using the API here. And if I go and look at the actual Redis database, I've got Redis insights here. You'll see now if I just refresh this here, this is attaching to that local Redis state store that's running on my machine. You'll see that I've written an entry here with that key called my app plus name. This is the key of it. And if I look at that, you'll see the data that gets stored is a key value pair here of the data itself, stored with a key over here. And all of this is versioned as well. So I can keep doing this. I can actually stick another name inside here. I can actually put, here another one here. I'm going to put another name here, name2. I'm going to put Batman in the store. And if I retrieve that back here and do name2, I see I get Batman. If I go back and look at my state store and refresh here, you see there's a name2 inside here, and this is Batman. And then the API provides you to do all sorts of interesting things in terms of transactional capability or deleting those entries. Or one of the ones that's very interesting I can do is I can do a bulk get. So if I go and call the API here and I say state store, get a bulk number of items, and I want to get the keys name and name2, and I run this, it'll return as part of the call onto this endpoint here, name, here is Bruce Wayne here, and name2 here, which is Batman. So you can see now that as a developer, I can now create a stateful application storing state into a database of my choice as key value pairs, simply by calling a local defined endpoint inside here. And all the heavy lifting of determining and calling onto that SDK for that particular state store and storing the information, retrieving it all, is all abstracted away from me. And this means that I have great portability around my code, and then how I can achieve calling for this from any language of my choice as well, because virtually any language can do HTTP, whether it's Rust or Go or C# or Java or COBOL for that matter, as long as it can do an HTTP stack inside here, or gRPC. So that's a kind of a very clear example of what these APIs provide you. Now, when you put this together into an application itself, Dapr actually runs, as a sidecar against many applications that you run. So I can run a Service 1 and Service 2, both have their own Dapr sidecar here. And Dapr will actually do the communication from one to another, or do the publish and subscribe messages between them all on my behalf. So now, if I just simply want to send an event from Service 1 to Service 2 through a built-in publish subscribe mechanism, for example, using a NAT server or RabbitMQ or Service Bus, I can just plug that in with the Dapr API in the same way that I just showed you with the state management. So this pluggability of components is key to Dapr, and it's been the key to the growth of the community, because now, I just showed you how I was calling into a Redis state store, but I can actually switch this out, and without any changes to my code, I can actually store state now in any number of different databases, making my code not only portable, but also easing the developer's experience about how they take advantage of that state. So the component model, that's this pluggability, along with the Dapr APIs that you call here, makes Dapr very flexible in the choice. And I want to stress is that, you can just choose the APIs that you want. Now, how you achieve this in terms of here's these Dapper state APIs that I showed you in order to save some state and retrieve some state is you define this component definition here. And you see this component definition here is I just set up an order store inside here and I use this for Redis. But if I wanted to switch this out and change this to a different state store, all I have to do is change this from a Redis state store to say a DynamoDB state store, and none of my code over here would actually change. So this is the adaptability of Dapper in terms of how you can actually take advantage of this component model in order to use it in different environments. So the end result is I might build an application that uses Dapper, stores its state inside Redis, uses RabbitMQ to communicate between the services and retrieve secrets from HashiCorp Vault. Or without changing my code in any way for Service 1, Service 2, Service 3, I can move that into AWS and switch out RabbitMQ for the simple notification service, store everything in DynamoDB, and take advantage of the key management service that has for retrieving secrets. Or I could actually switch that out again and run it on Azure, for example, and put my data inside Cosmos DB as a state store, and use Azure Service Bus as the communication mechanism with the Key Vault, Azure Key Vault for this. And each one of those times is my code doesn't change. So this is the flexibility that you get in the portability of your code. Now, one of the great things about Dapper is it's been a community driven. When it was released in its first preview in October 2019, there's been tremendous growth from that. And in order to fuel that growth, you'll see that there's been nearly 1,800 contributors. In fact, it's close to 1,800 now. These community donated components for plugging into different systems. There's a big community of just under 4,000 Discord members, and there's contributing organizations that consist of many different genres in terms of Zeiss, which is an optical company, all the way through to Bosch, which is a manufacturing company, to Alibaba and clouds like Alibaba and Microsoft. So this growing community of organizations has enabled the project to become very well contributed to and growing rapidly. And last year in November, Dapper was donated to be part of the Cloud Native Computing Foundation, which means that the Cloud Native Computing Foundation are the ones that are sponsoring it and sponsors its growth. And we have sessions that happen at KubeCon if you're going to be attending that in Europe or in North America later this year. So there's community growth with regular releases. You'll see that there's releases for 1.6, recently 1.7 in April, and coming up 1.0 in June. Has driven and fueled the growth of Dapper in many organizations over time. So let's dive a little bit more. Actually, I'll pause at this point and see if there are any questions in Slack, or if anyone wants to ask me questions at this point. I'm looking here in the Slack room for Slack B. I don't know if anyone's posted any questions there. Feel free to kind of post some questions and ask them all. I'm happy to take questions on the way, just to kind of get because I know sometimes things go fast and you want to have a burning question of these things. So let's dive in a little bit more about Dapper building blocks. As I stressed, each one of these is totally independent of each other. So if all you want to do is build a stateful long-running application with a state management building block with Dapper, that's all you have to do. If all you want to do is use Dapper to retrieve a secret because you want to communicate and talk to a database, you can. So you can just pick and choose what you want. And so you might end up an app that uses, get some configuration data, or it's using service-to-service invocation by calling a method on another service, or secrets management. So a wide variety of different capabilities are enabled in your, depending on what you're trying to do, whether you're building a new application or whether you're migrating an existing one. Let's dive into service invocation, because this is one of the most commonly used ones inside Dapper. And what that allows you to achieve is it allows you to launch two applications, and for one application to call methods on another, in an RPC-like way. So in this particular case, both of the applications get launched. They both have Dapper running them as sidecars next to them. Inside my checkout application here, I can call the invoke method and say, call the orders method on the order processor method wherever it's running. This could be running on another VM on another machine. This could be running on my local machine. This could be running inside a Kubernetes environment. Dapr does the hard work of sort of doing the discovery of where the component is, doing name resolution for this, encrypts all the data on the wire. So the important thing here is that Service Invocation does encryption on the wire, it does retries, and it does discoverability. It calls onto your other order processor endpoint that you've set up. This is one here called orders, and then you get a response back. So all of this is taking care of you: security, discoverability, retries, retries on event of failure, and discoverability of the process itself. Or just simply because you just call and take advantage of a post method. So let's go look at this in code, and this time now, what I can do is I want to switch to show you some real code. I showed you the API here before, but I'm going to show you those two particular applications. Now, I've switched here to using some C# code, and these are one of the quick start getting samples we've had. And in order to take advantage of that, you'll see that this is this checkout order service, and this is the order processor service. So let's look at the order processor service first. All this is inside the C# code is this is C# .NET 6.0. So you see this is a minimal .NET application. And you'll see that I launch a web listener inside here. And then I just have a single endpoint here called orders. And it just posts what my orders are received. And then there's a particular structure to my order, which just contains an order ID. So here I am, I can run the order processor service that's just listening to orders. You'll see that there is no code in here about, this is just typical REST endpoint code. There's nothing special about this that I would write just anyway when writing a .NET application. And then here, I can take advantage of of calling and sending an HTTP request, doing a post method sync here. And if all I simply want to do is take advantage of posting the message, all I have to do is reference the application ID name of the order processor. So this order processor now I will launch with this order processor name. And now by simply including in the request header the name of the application I want to talk to and sending the request in the body of the message, and you see here, I take the order method here and serialize it into JSON and then just post it to this orders endpoint. Dapr does all the hard work of discovering it, and calling that orders endpoint for me on my behalf. So you see here, this is very, very natural code for a .NET developer, for a C# developer, for a web developer for that matter. There's nothing inside here that is kind of very different from what I'd write normally. So I'm going to switch over here and pull out two little consoles. So the first thing we're going to do is we're going to launch the order process. Now I'm going to use the Dapr run command here again. I'm going to launch the order process and say it's listening on port 7001. This is the app ID order process here. I'm going to communicate with it over HTTP. And I'm going to use this .NET run command here to launch the application and the Dapper sidecar together at the same time. So you see here now I've launched my order process. If I switch to here a moment and just do a clear and then do a Dapper list, you will see that I actually have, I still have my old one running over here. So let me just kill this one off a moment. Let's just kill this one here. Let me do a Dapper list again. You'll see now I just have my order processor application and I killed off my one that we had testing here beforehand. And here it is running and it's listing on port 3500 for requests. So now what I'm going to do is I'm going to go to the checkout application here, which was this checkout code upside here. And I'm going to do a similar sort of thing. I'm going to use the Dapr run command. And this time I'm going to launch it with an app ID called checkout. And it's going to launch Dapr as a sidecar process for it, talking on 3500. I had to choose a different port because I'm running them on the same machine. If it was running on different machines, I could use the same port. And if I run this here, this will launch my application, the checkout process, and it'll start posting 10 orders. And you'll see if I go back to the order processor here, I'll start receiving those orders. So what I've done now is I've simply called between two applications in a very natural way, and Dapr has done all the heavy lifting for me. It's called the application, and if I failed one and recovered that application, Dapr would carry on. So it'd be resilient, scalable, and discoverable. And my code is very natural. So that's kind of doing service invocation as a way of showing it in code. What I should say, actually, if you want to go and try these out yourself, you can actually go to the quick starts we have, and you can sort of try these out here. This is a service invocation sample. There are actually also SDKs that actually have an experience that allow you to show a more RPC-like method. So, for example, if I go and show you the C# way and just show you the checkout order processor inside here, you'll see that another way that you can actually achieve this thing is actually I can have a client, which is a .NET client here, and I can do publish event async and do publishing of a message with an order here like this. So as well as that HTTP method, I also have a sort of a first-class method endpoint on an HTTP client, on a Dapper client, in this case, .NET. That gives me a sort of more direct experience. And inside the invoke world, that's as an invoke method as well. So let me switch back to the slides here and keep going. We've already seen state management, or I can state orders inside a database, and I can call back and I can retrieve those orders. So here I can go and call my order store here and get back my order. And the beauty of that is that whether I was using Redis cache before, I can now switch over to DynamoDB and exactly the same call happens, and for my code doesn't change. So we can put this all together now and put together the service management and service invocation and state management into a single application where I can send an order between two applications. And when I receive that order, this time now I'm going to reply back and save the state of my application into my chosen state store of choice. And that can be any one of the numerous ones that Dapr supports. So I'm going to combine those two those methods together into a single application now and show you a demo of that. So let me switch back to Visual Studio here. VS Code here. I'm just going to sort of minimize this over here. I may pull up another application inside here. So this particular application is now I'm switching languages here. So I'm switching to a Node application. So this is my Node application here, actually, and a Python application. So we're switching different languages. So let's do the Python application first here. The Python application is now in the same vein as we saw with that order processor one in C#. It's simply the Node application is in the same vein as I saw with that C# application here. You see that actually, if I scroll down here, there's a new order method here that I have, which retrieves orders. And then I take that order method that comes in, just as I was calling that orders endpoint in that C# application. But this time, I can actually take the information that comes inside the request message here, and I can build up a new order here and send this as a JSON message in order to save its state and calling the state API. So you'll see that this state API here is very much in the same vein as we saw inside the state API I showed you before. I can call a local API on the Dapper port of my choice, calling the state store of my choice here. So this state URL here calls onto that local state store I've got, which is that local Redis database I've configured for that. And so, now I can receive messages on my new order method endpoint and call the state endpoint here and save that actual particular method here that I retrieve here in this order data that I retrieve from the request message that comes in the body of the data here. The Python application simply is sending orders in the same way that we saw that C# application sending orders. And it is doing a set of orders. This time it's going in a while loop. There's not just 10 of them, it's constantly sending orders. And just as we saw before, it contains the app ID here saying node application and calling it node app, which is this node app I just showed you over here. So here I build up my orders and I do a post message onto the Dapper URL here. And you'll see here, I'm calling the localhost new order method. So I'm using service invocation to call the new order method on my node application. And inside my node application, I here I'm sorry, my node application here, I'm using the persistence method here to persist a state. So let's put both of those together here. I'm going to run the node application first, which is the order processor one, so it's up and running. And actually, let me just check to see what I've got running here. I think I've just got, if I do a clear and if I do a Dapr list, I've still got my order processor one running from here. So let me just kill this one off a moment. Let's just stop that. Let's just go back here and check again. Yep, so I just have my node app running at the moment, which is this one we just launched here. And you'll see here, this is the node app listing on 3500 now. This is like the order processor running. And now I can actually, if I just do a clear here, I can now run my Python application. And you see if I run my, my Python application, which is a long way back here. I'll keep going here a moment. It's been a while since I run the Python application. Let me, here's my Python application. So if I run the Python application with the Python app ID and I run it as a Python command, this is the app.py here. I'm launching the Python application, and this is the one that's posting the orders at me. So now what you'll see is that I'm actually seeing these orders be retrieved, sent from the Python application through service invocation, and I've made a stateful application here that's long running as well in the code. And you'll see that this keeps running. And if I go and look at the Explorer again, and if I just refresh here, you'll see that here's this order coming in. And if I see this order ID, you see the order data is changing. If I just refresh this, you'll see that the order ID here is changing inside here. It's going 34, 35, 37, which corresponds to the orders that have been posted inside here. So a lot is happening here, doing calls between processes, applications, discovering where they are, making one of them stateful. But what's more is that Dapr actually tracks all of these and keeps track of all this information for you. So I can actually go in and actually now use and the observability built into this to take advantage of looking at all the calls that happen between my applications. So if I just go back here and look at Zipkin, you'll see that using Zipkin, all those traces are done for me on my behalf. Dapper keeps track of all the calls, understand what's happening, and I can see sort of dependencies between my applications for all those events. And you can see now, oh, because I've been running both the checkout and the order processor application, and right now you'll see this messages going between my Python application and my node application. Let me just make that a tiny bit bigger if I can. I can't. Looks like it's going to be small, but you'll see all these messages going between my Python application I've just launched and my node application. And Dapper does all these traces for me. I can actually even go in and look at these traces inside here and run a query. And here's this Python application. And you'll see that I can show this whole call stack. The Python application called a new order method on the node app, the node application, and this is the time it took. So this is the end-to-end time of 15.971 milliseconds, of which most of the time was spent on the network calling the node order app. And then you see here that the node app actually called onto the underlying state store in 6.093 milliseconds. So this traceability here of between services and down to the actual state store itself allows me to have really good visualization and debugging, particularly in production. And I didn't have to do any work for this. Dapper did all this on my behalf. And as your applications get more complex, Dapper does all this tracing for you so that you don't have to start putting any of these tracing calls into your application. I think this is one of the coolest features of Dapper does and helps you kind of achieve your goals of really building resilient, visible applications. I've just switched back to room B here a moment, see if there are any questions. Doesn't seem like there are any at the moment. If there are, just please post them inside here. I'd love to hear any questions you have so far, just to kind of get your idea of this. All right, let me switch back to the slides here. Keep going. I kind of just put this inside here just to point to the fact that Dapper, although it just does, I showed you the key value status inside there, it does many more things that built on top of that, just abstracting sort of SDKs. It can do things like transaction groups. If you're writing to a state store, it can do strong and eventual consistency inside the state store. It can actually flag values that you write into your state store with time to live. So I can write these time to live value against this and say, after 5 minutes, I want these values to be automatically removed or deleted on my behalf. So all of these things that help you build stateful applications, layering on top of capabilities that you may not necessarily have in the state store that you're using. And so, you've got the theme now. If I go through and say, yes, you can use publish and subscribe, and you can use a Redis in order to distribute events from one message where I post a message using the publish API to publish an order event, and then that order message gets distributed to all the services that are subscribed to it all. In this case, service A and service B will both receive an event that they publish to. Extremely important mechanism. And Dapr then layers on top of this guaranteed at least once delivery. It does retry mechanisms inside this, and lots of other capabilities to make your application resilient. And of course, as I showed you with the state store, I can plug in any number of these components. If I didn't want to use Redis cache, but I wanted to use GCP PubSub, I could instead. My code doesn't change, nothing, the events still get delivered. Or I can be triggered with external events. I can be triggered for events that appear on Kafka Q, or a Twitter event, or messages that get posted into databases. So external systems can come in and trigger my application and call the new tweet endpoint that I have in my application. Or I can trigger external systems. There's a Twilio binding. I can write out to the Twilio binding and say, Twilio, send me an SMS message on my behalf, just calling the Twilio binding API, and Dapr will send off messages over Twilio for you as part of its integration, without you having to learn and understand the Twilio SDK. You just have to understand a simple REST call. Secrets. A number of customers we came across who simply wrote a piece of code in order to retrieve a secret from a secret store in order to talk to a database was immense. So we abstracted that to say, you can plug in the secret store of your choice, in this case, HashiCorp Vault. I can call onto the secrets API, get back my secret from the secret store called Vault in this particular case. Or application configuration. An application starts up, it wants to load some configuration for doing what is needed. There's a configuration API that you plug in different types of configuration stores to. So you get the idea. This allows you to be very, very flexible in terms of what you choose. Just pick the API that's necessary for your scenario. Now, one of the most common places to run Dapr is on Kubernetes. I'm sure you've all heard of Kubernetes, but of course, if you're having to build on Kubernetes, Kubernetes is a complete pain because it's got nothing to do with the developer. So we did deep integration by taking Dapr, a Kubernetes cluster, and deploying a control plane that does all of the necessary integration into a Kubernetes environment, such as injecting Dapr as a sidecar for you, and doing certificate management for you, and managing and updating components on your behalf. So when you launch your application in a Kubernetes environment, all of this is taken care of for you in terms of launching your application, launching Dapr as a sidecar, and being fully integrated into a Kubernetes environment. Now, Dapr will run on VMs as well, and we have a full integration with that. It's just Kubernetes is one of the environments, and it can run on other distributed hosting environments as well. And so this integration then allows Dapr to take advantage of running Kubernetes on any one of the different types of public clouds or on a local instance. You could run it on Minikube on your machine. Any Kubernetes deployment will suffice for Dapr. And it'll integrate with all the components and APIs you see here before. But this control plane allows me to have a rich experience of Dapr inside a Kubernetes environment. So let me take that application I showed you just now, and now I'm going to go back and show you a GCP cluster here. I got a Kubernetes cluster here. I've deployed Dapr to this. How did I deploy Dapr to this? It was as simple as me going to my CLI, and let me just stop these two instances here a moment. Control C and just Control C this as well. If I go to my Dapr CLI and I just do Dapr init -k, that will deploy Dapr to your locally configured Kubernetes cluster. And so that's exactly what I've done. I have the Dapr control plane here deployed. And then I took exactly that same application I showed you, that Node application and that Python application, and I build them into containers, and I deployed them into this environment side here. And you'll see that I have, sidecars running for both those Node applications and that same application. No code changes, just containerized. I have Redis and I have Zipkin running here again. And so now what I can do is I can go and look at, I can actually know, and let me pull up a command here. I can actually now go to that particular Node application, and I can hit the endpoint that it's listening on. And the same we saw the orders before, here's the same orders that are coming through for that same Node application. It's just pulling back an open endpoint that I have, that order application, be able to see them all. I can actually go in and actually can turn on port forwarding here for my Kubernetes cluster. So if I just do Control-C here, and I do turn on port forwarding for that particular Kubernetes cluster. Now as port forwarding, I can actually go into that particular Zipkin environment, and you'll see now that this is the Zipkin environment that's running on my Kubernetes cluster. I can do exactly the same visualization of the same messages inside here. I can go off and find those traces again, and I can find all those same traces that I saw before shown here inside that cluster environment. So, without any code changes now, I was able to deploy this, and all I had to do was deploy this as components and YAMLs inside here. As Kubernetes YAML definitions in a very similar way that I deployed to my local machine. And in fact, I should be able to show you one of those. If I actually scroll down here and look inside here and look in the deploy YAML for this, you'll see that all I had to do was to declare a deployment manifest here inside Kubernetes. And I just simply had to give the name in the same way that we had to give the name inside the CLI. I had to give the name as an annotation here to say the name of this application was Node application. So I just said, enable a Dapr sidecar when you launch it, and here's the name of my application here, and listen on port 3000. And then here's the container image I built for that Node application that you can do yourself. Same with the Python application here. I just took a deployment, I called it Python application, I launched Dapr sidecar. So this really is the CLI equivalent that you saw me do earlier in the Kubernetes world, Node code changes, but now I'm running it in production. So this gives you the whole flexibility of switching between easy local development, deployed to Kubernetes, and building really complex applications on Kubernetes, because Dapr gives you all those building blocks. Let me switch back to slides here. That's the Kubernetes view. I showed you the distributing and call tracing inside here. I think one of the key values of this. And one thing I thought was fun to highlight, there are many, many things that Dapr can do for you. But one thing that we introduced recently is resiliency policies. So I showed you all these APIs, and the question is well, okay, how do I make those things more resilient? If I'm using one of those, how do I provide resiliency on, when I would do state management, if my database goes down, how do I know that the state can recover? Or if I call from one service to another and it fails, how will Dapr do the retries for me? Well, the answer is you can provide resiliency policies to Dapr against the components themselves, as well as between applications. And you can provide those in terms of retries, how many often I retry and talk to another service before it gives up. Timeouts, how long do I wait until I don't stop trying again to call a service? And then importantly, things called circuit breakers, which is a way of me tripping a switch when something fails, waiting for a period of time, trying again with a few more requests. And if it recovers, keep going and fully open up. If not, fall back and keep going. So these are resiliency policies that you can supply and attach to your application and the calls between them all. They're available to, against all of those APIs that I showed you earlier. So for example, if I'm calling from that checkout service to that order processor service and it fails, the resiliency policy will kick in for however I've set it with a circuit breaker. Or if I'm calling into some outbound component, for example, like a Redis database, and that fails and goes down, the resiliency policies will kick in and do this. So I should be able to do a demo of this. I think I got one working earlier, but let me at least show you what the resiliency policy looks like. Actually, now I have to go back and remember if I had the resiliency policy on this machine here. Let's just have a look at the moment here. No, I don't think I, oh yes, no, I did. Here we are. So here's a resiliency policy that I might have determined inside here that I've set. And this particular one sort of sets a circuit breaker that allows me to do the number of consecutive failures on this particular application. So I think I set this up. Let me just try this out and see how it goes. That on my local application, I loaded up these resiliency policies and had them running. So I'm going to give it a go and see what happens and see if the demo gods are with me. So let me just switch back here a moment. I'm going to launch my Node application. I'm going to launch my Python, Control C on this. I'm going to launch my Python application inside here. And I believe I set a resiliency policy running on these as well. So what should happen is you see I'm successfully persisting orders inside the database inside here. And what I'm going to do is I'm just going to switch out here and I'm going to do, let's just stop this for a moment. I'm going to do a Docker PS to see my running processes. And I'm just going to kill the Redis process. So I'm going to do a Docker kill B22, so this should kill my Redis instance. Let's see what happens inside here. And you'll see that it started to fail persist state. And I don't think I set the resiliency policy inside here to recover. So yeah, the node method is failing inside here. And you'll see that I didn't set up the resiliency policy. But what would happen is that you'd see a circuit breaker kick off and it would say a circuit breaker has been tripped. Do you want to recover and recover the state for this and continue retrying inside of this? But that we'll leave that for a demo for another day. The important thing here is that I actually could set up this resiliency policy running inside here. I have to remember how I have to set that up again. I'll have to go back and see if I can check up on that. So yes, so that's the end of this. I fully encourage you to come and join the community. If you come to Dapr.io, we have a thriving community in Discord. If I just launch Discord here, you'll see that in our Discord channel, you can come. I just want to show you what this looks like. If I launch Discord, there is a Dapper server inside here. We have channels to talk about observability and general and security and state management, secret management. And it's a thriving community with a lot of people helping out each other. So I encourage you to check that out. I encourage you to go to the Dapr.io website here and sort of install the Dapper SDK, getting started inside here, and try out these quick starts that I showed you today. There are two sets of quick starts. There are these simple ones that just shows the API, but there are some more in-depth tutorials here. And in fact, I showed you today the Hello World and the Hello World Kubernetes tutorials. So if you go inside here and step through this tutorial here, this was this application I showed you here with this Python and Node code inside here. And it takes you through a detailed sort of steps of how to configure it up, set up your application and talks through the code. So there's some more detailed walkthrough tutorials inside here as well. And just to show you the breadth of what Dapper's done, you'll see that I can go here and all those state stores I showed you. This is the list of the 23 or 24 different types of state stores that Dapper supports. Aerospike, Apache, Cassandra, Cockroach, Couchbase, HashiCorp. These are sort of the general ones that we have, including Redis, Postgres, MySQL. And then there are one specific particular clouds like AnamoDB, GCP Firestore, Azure Blob Storage, Cosmos DB, or Oracle Cloud. And so this allows you to take advantage of those state APIs, simply plugging in the component definition of your choice. Or you may choose, for example, to take advantage of the pub sub brokers. And you'll see here we have Kafka, Hazelcast, MQTT, NATS, and in-memory Jet Streaming, Pulsar, RabbitMQ, as well as ones for Amazon, GCP, and Azure as well. So there's a wide breadth of these things. And if you also want to kind of be reassured about, well, who's using this and who's using Dapr today, two things I'd love to point you out to is that there are a set of case studies here. And if you go to these case studies for Bosch, Zeiss, Ignition Group, Legentic, all running on different platforms, great to read their case studies around they are. Or if you actually go to our GitHub repo, you'll see you'd actually feel free to kind of start to understand what the repos are here and contribute to part of these. But you'll see inside here, we actually have a standing issue of are you using Dapr? And this is a whole collection of people who've been self-reporting about how they use Dapr in production environments. And if I scroll to the bottom here, for example, just on this page here, just the other day, we had a company here called De facto Technology in Turkey, who talked about their installation, their Dapr, and they're running it in production. We had Vision, which is also sort of running Dapr in production. We have IBM Research, who are evaluating Dapr inside here. So you see the names of some pretty big and medium-sized companies inside here, including Microsoft building it inside their cloud platform. And all the way up here is Fujitsu Cloud. So, these ones are that Dapr is been around and is being heavily used inside some very large deployments and is continuing to grow in terms of its stature and in terms of resilience, and is being used in many, many different types of scenarios today in different terms of applications. So at that point, I encourage you to sort of check some of those resources out. I will just switch over to Slack and see if there are any questions, and willing to kind of hear any of your feedback. So here's one. How does Dapr deal with OpenID Connect secure API? The good question. I don't know the full answer to that one. Well, OpenID, so you can provide an authentication protocol. If this is about how do I do OpenID authentication via Dapr, you can. Dapr has this concept of middleware. So you can actually go down, if I just go back to here and go to the repo, actually, so if I go back to the docs, I go to docs.dapr.io and show you here, you'll see that there are a set of middleware components. And inside middleware, you can actually do authentication through the middleware here. So for example, if you're doing OpenID Connect and you want to provide an ID authentication here, you can do like OAuth credentials that you provide to that. I think that's answering your question. So through the middleware side capabilities of Dapr, you can provide authentication credentials that get handed to your, that the middleware takes care of retrieving those, reaching out to the authentication provider, authenticating against that before continuing to call on to your particular Dapr endpoint. Hopefully that answers the question. Completely new to Dapr here. Dapr sounds like a wrapper to existing functionality. We create our own APIs for services to connect to. How is Dapr different? Well, if you're using your own APIs, that's great. I mean, I'm not trying to discourage you inside here. The thing that we found with Dapr is that, what happens is that the pluggability, the important thing is this pluggability, is that you can switch out and do these different types of component databases. So I'm sure you have your own APIs, but you've probably tied them particularly to some particular, SDKs, and they're very specific to you. The thing about this is that Dapr allows the portability across clouds. It allows you to swap out each one of those different types of components. And it's also being adopted as kind of, and solely as an industry standard. the goal of having it adopted into CNCF is very much in the same way that Kubernetes provided an agreement about how you can host a distributed systems platform for hosting and running code. Dapper's APIs are sort of becoming a steady agreement of how do I have a consistent set of APIs for me building distributed applications. And the answer is, you can actually use your existing APIs alongside Dapper. We're not asking you to remove any of those, but maybe just one of the Dapper ones might be useful that you don't already have, like a secrets API. No specific questions, but looks amazing. Oh, well, thank you. Yes, we think it's amazing. Is there a particular first use case that's common for clients to use as a way of getting started with Dapper? Yes, like one of the most common things we see is like you just want to do pub-sub subscription between your application. So you want to take an application that wasn't event-driven and you want to turn it into an event-driven application. And so you just run Dapr as a sidecar. And now I can say my application can listen on events and become an event-driven one. And that's very important for decoupling your applications around. So we see a lot of applications that were built, as a compiled type of single piece of code, and they have to disconnect them from a business perspective because they want them to scale independently, and then they become event-driven. So when I decouple applications apart and make them event-driven, Dapper's for that. Or the secrets one as well. If I want to just, we saw numerous cases where I just wanted to have a secret that I retrieved. And rather than me having to learn the secrets API for Azure Key Vault or HashiCorp Vault, I simply launched Dapr, and Dapper's done all the hard work for that integration for me already. That's been tested. So event-driven scenarios, breaking apart existing applications, building resilient service invocation, talking between services, and also building sort of stateful long-running applications. If you want to build that sort of long-running shopping cart. We've also seen a lot of IoT applications where events come in, they come through some IoT system. So hopefully that's given you some ideas. Read those use case studies. They kind of teach you through. And yes, thank you for pointing this out, Adi. There is a great free book that actually we helped kick off and get written that I should have put in the resources there that tells you how to use Dapper from a .NET perspective. And that goes along with that. There's some great tutorials as well. So follow up on look for, workshops, I should say. That particular book there has a workshop associated with it, and the workshop is in both .NET and Java. So feel free to go and try it out. And that's another great way of learning Dapper. So with that, I will stop sharing and I will say thank you. And I hope you enjoy the rest of your day.
Thanks very much, Mark. That was a great presentation. Thank you for being here today. And thanks for the questions and the comments from the audience members. Is there a particular, real quick, we're actually out of time. Is there a particular case study that you're particularly proud of, or you think is a very representative one to check out?
I would check out the Zeiss one, which is where they used it as a business application to deploy an application that runs on each one of their different types of manufacturing plants, and how it did that. And it was very insightful when it did that. That's just from a end user perspective. The other one I think was fascinating is how Alibaba took Dapr and is used in Alibaba functions in their cloud. So it's a core part of running on literally hundreds of thousands of machines inside Alibaba where they do their functions runtime. And so Dapr is being used not only in end user applications, but in other serverless platforms like Alibaba, and also in Microsoft's one. So checking out Microsoft's container apps, I would suggest those two.